So this video was about the myFP2ESP32 ESP32 controller, and what I intend to cover in this video is a significant amount in a short period of time. So apologies if I seem to go too fast. I'll discuss the firmware, I'll discuss how to configure the firmware, I'll discuss the management, TCP/IP, web and ALPACA servers that run on the actual ESP32, and I'll look at other things that support it, such as the Windows application, the ASCOM driver, the Linux chip and INDI. So that's what I'll talk about, but I must point out that you should really read the Focus of Basics PDF first, because that contains a significant amount of information about how to determine critical things and settings for your focuser, such as step size, step mode, max steps, and all that information is really critical if you want your controller to actually perform well. Right, so here I am, I'm using drive D, and I've created a folder called myFP2ESP32 ESP32, where I intend to download all those particular files. Right, so I've got a web browser here, and so what I'll do is I'll just go search for myFP2ESP32 ESP32. Oops, sorry. myFP2ESP32 ESP32, and just search for that, and there it is. Oh, sorry, wrong one. It's not there. It's here, because I don't use GitHub anymore. Right, so let's go here. This is where it is, and I'll go into Files and start downloading the documentation. And once I'm done with the files, I'll come back to Home, and then I'll go into the firmware and do the rest. So I'll start downloading these now. Right, so here we are. I'm in the folder that I've created to hold all these project files. Now, I've downloaded all of those on the download one page, and what I'm going to do next is I'm going to create folders such as firmware, docs, Linux, Windows, ASCOM, so that it becomes much easier to manage these things. Right, so now I've got all these folders created and I've moved all the files into them. It's going to be so much easier to manage because this is a fairly large project. Alright, so we're going to download the Arduino IDE first. So we'll go to the particular link, which is this one. We don't want any of those, so we're going to scroll down to some old code down the bottom here, this one, and this is what we're going to have. So I'm running Windows, so I'll download that, and we'll download it. Doesn't take too long, and I'm going to stick all of these in the same folder that I had before on my D drive that I've created. So I'll do all of that now. Right, so I've downloaded all the Arduino stuff here, as well as the various libraries that it mentions. And my next step is to install the Arduino IDE, and you just run this file and let it go, and then we'll come back. Right, so I'll download the firmware file now, and then I'll extract all the zip files. I think I've done most of them anyway before this. I'll make sure that the ESPFS tool is visible in the Arduino, and then I'll import the libraries into the Arduino IDE. Right, so I'll go back to the project site, and the files the firmware file is found in this file, and what I would do is download the latest firmware from this as a zip file. It's not 304 by the way, it's 306-3, which will be uploaded soon. And once I've got that zip file, I'll then unzip it. So I've got the correct file now, and it's been unzipped, and I'll just go into here and go into here, and this is where the main firmware is. And notice that there's a data folder. That's the sketch data files, which contains all the websites and other config information, and the defines folder, which actually has definitions for the various settings within the controller. We'll talk more about those in a moment. Right, so now we're going to load this into the Arduino IDE. I've actually got two versions of the IDE installed on my machine, so I'm going to use the 1.8.19 version, because if you try to compile and upload this into the very latest version of Arduino, it's going to fail. You'll notice that there's a controller config file, and this is the file which will do most of the work in. But I need to ensure that I've got the sketch data upload is actually in here, because we need to upload a lot of data files, and they are, you'll notice a folder here called data. This contains all the web files, etc. The boards folder contains definitions for all the boards which are supported, and there's a defines folder which has got some other settings information associated with, and I'll talk about these soon. So we're currently working in the firmware. This is it here. I've made sure that I've got access to the sketch data uploader, and my board has been set correctly in here. If it's not recognizing the ESP32 chips, these boards don't appear in Boards Manager, then you will have to configure this, and that's covered in the PDF. Right, so this controller works in two different ways depending upon how it's configured. When it's configured as an access point, what that basically means is the chip itself actually creates its own Wi-Fi network, and other stations then have to connect to and log into this network. The network by default is myFP2ESP, and same for password. So you can do that, because if you're out in the field or whatever, then you won't have any network per se, but what you can do is operate this controller as an access point, and then your laptop or your phone or anything else that you're using can actually connect to this network, and you can control it by using these devices which are connected to it. The other mode is station, and when the ESP32 chip acts as a station, it actually logs into an existing Wi-Fi network. And so for example, I would run an observatory which I need access to the net and everything else via Wi-Fi, so I would have a local network that I've created. It's called Firefox, and it has a specific TCP/IP address associated with it, and all the other devices actually connect to this Wi-Fi router that I've got here called Firefox, and that means also that I could access the ESP32 chip via the internet or from another country, etc. So it's ideal for remote observatories which have access to the internet. Straight out of the box, the firmware supports the following devices, such as the ALPACA server, the management server, TCP/IP server, web servers, as well as the devices such as the home position switch, the LEDs, the push buttons, joysticks, and temperature probe, and all configuration of those is done using the management server. Nowhere do you have to specify that they're enabled or anything else as part of the Arduino IDE. The things that you do, however, have to specify in the firmware configuration is whether you're using duct DNS, infrared remote, OLED, or the OTA over-the-air updates, which is optional. So now we'll go and have a look at the actual firmware configuration and see how these things are specified, etc. So here we are back with the Arduino IDE 1.8.19, and we'll go through and have a look at what needs to be done. So the first thing we come to is a thing called the config section, which says edit this file, so and specify a whole range of things. So let's go to that config file. This is it. First thing you do is you have to define a board. So for example, if you're using the PCB for the DRV8825, this is what you'd use. And there's a whole range of different boards. The ULN 2003, the L2980N, the L293D Mini, and so on. These boards, or if you wanted, of course, to use the TMC chips, there's boards just dedicated for them. So I'm using a ESP32 with the DRV8825 chip, so that's what I'll choose. The next thing is fixed step mode, and for only 3 odd boards you need to set this value, and because I'm using a DRV8825, really doesn't matter. And motor steps per revolution again is applicable to a number of boards, and if you're not using those boards, it doesn't really matter. And now we come to how will this chip actually work? Will it work as an access point, or will it connect to an existing Wi-Fi network? And that's what I'm going to do. So I define here a controller motor station. The IP address is actually coming from the Wi-Fi network when I log in. So I'm using dynamic IP, and I'm going to also enable this because of the fact that I like to keep the login details separate from the firmware. So I'm using a separate file to do that, and we'll have a look in a sec. I'm not using any OLED driver at the moment. I'm not using a infrared remote. I'm just going to disable this for a sec. And yeah, let's chuck in the over-the-air updates as well. So these things, starting here, display driver type, the infrared remote controller, and OTA and duct DNS. If you're actually using those, they have to be specified and enabled here before you program the controller. If you program the controller, let's say with elegant OTA disabled, which looks like this, then the code for all of this doesn't appear in the firmware, which is generated and uploaded. So if you want to add this later, you actually have to reprogram the controller. So that's what we've got. There are some other files that we'll have a look at here, and they're in the defines folder. Now it says here, let me just scroll back to station, it says edit station defines. So we'll go back to the file, edit station defines, and we'll have a look in there, and it tells you what your network login is for your network. If you have a different network also available, you can specify that, and it also specifies these parameters, but these only apply when you use a static TCP/IP, and I'm actually using a dynamic one because that's what it says in controller config back here. Alright, dynamic. So the other thing was I specified elegant OTA, so let's just go back here and have a look. There is OTA defines for that, and this is where I can specify what the username and password is and the identifier, which is used for the over-the-air updates. So I can set these to anything I want. Right, so that's all the configuration that would, and there is a reminder of course here that if you're using OTA updates, well, you better go and change some things. So that's everything we've got, so let's go. Here we are. Yeah, it's been successful compiling all of that, but there's one thing I want to do before I actually do the sketch data upload, etc. And that thing that I want to do is make sure, because I'm using the read WebPy config, I've got my config in a special file called myFP2ESP32. So what I'm going to do is I'm going to, in the data folder for this firmware, what I'm going to do is I'm going to put my WebPy config files in here. So I've got two of them. This is for the multi-config, and if I open that up, you can see you can specify here what those passwords and IDs are, etc. So that's already done. Right, so now that I've got all of those, I want them there so that when I actually upload the firmware and the data files, they are included. Right, so what we would do now is make sure that our ESP chip is actually connected and recognised on a COM port, and all I would have to do is do the upload button. I just click this and wait for it to be uploaded. When it was finished uploading, then my next step would be Tools, ESP32 Data Sketch Upload, and that will then start the upload process for all the supporting sketch files. And when that's complete, the controller will be running. We'll talk about in the very next video what is needed to be done to the controller to make it work like a focus controller with all the correct settings done. Part 1 is about generating some firmware and loading it up to the controller, but that's actually not usable until the post configuration phase is done. So once that's completed, the focus is ready to use. So to do the post configuration, we'll do that in the management server, and then to test things, I'll install the Windows application and show it connecting to the controller.